Okay, so now we will start again. Keep your audio and video mute, otherwise it will make disturbance. Whenever I ask some questions, you can unmute and you can tell your answers. Okay, so up to now we have seen gamma z, gamma z plus 1 is nothing but z times gamma z, and then we have calculated gamma 1, gamma 2, gamma 3 and gamma 4 and so on. If I do, what is my gamma n plus 1? Gamma n plus 1 is
n factorial.
N into gamma n.
Gamma n, and which is nothing but my n factorial.
Factorial.
N factorial. So this is the relation. This is about application of this. You can call this as. Please, everybody mute. Whenever you answer, then only you unmute. Who is Rani Naugare? Tuja Bidwe? Please don't disturb the class. Okay, so this is one type of difference equation. Now we will see another application, another example, that is Euler's method. Example 1.6. This is sixth example, right? Euler's method. In Euler's method also we come across some type of difference equations. So what is Euler's method? It is used to solve initial value problems. Initial value problems in numerical analysis. What is initial value problem? X dash of t is equal to f of t, x t, and x at 0 is equal to x0. So Euler's method used to find numerical solution of this initial value problem. What is initial value problem? Everybody know initial value problem, boundary value problem?
Yes, ma'am.
Yeah, what is initial value problem? What is difference between initial value problem and boundary value problem? Nobody knows what is the difference between initial value problem and boundary value problem?
Differential equation in which the initial conditions are given.
Yeah, initial condition is given. What is mean by initial condition? The value of the function is represented at only one point, like here 0, initial point. Usually we consider as 0 as our initial point. We can have 1 also, 2 also, we can start from 1, 2, 3, but usually we approximate our initial value problem when we give initial condition, we consider from 0, like starting point at 0. Okay, so and if value of the function is prescribed on more than one point means x at 1 is equal to 0, or x at 2 is equal to 0, like that, or x at infinity some another point, then like here value of the function is prescribed at 2 points, more than 1 point, no? Then we will call it as boundary value problem. Is that okay? Initial value problem means all values has been prescribed at only 1 point, single point. Okay. And in boundary value problem, more than 1 point, if I am having value of the function, then we will call it as boundary value problem. So I will erase this. Let me erase this. Rani Naugare, please mute.
Mute madam.
Okay, so consider this initial value problem. Consider the initial value problem. X dash of t is equal to f of t xt. Now we want to approximate its solution. So what we do, we replace this x dash of t by its approximating value. What is the approximating value of x dash of t? I can write x at t plus h minus xt divided by what I can write, because x dash of t is nothing but limit h tending to 0, x at t plus h minus xt divided by h. So approximate, if I remove limit, approximate value I can replace x dash of t, I can replace with its approximate value like this. So I will get here x of t plus h minus xt divided by h, and which is nothing but my f of t comma xt. I want to
xt
somehow difference equation. Okay. So now, so if I write the, if I simplify and write this as x at t plus h is nothing but xt plus h times f of t xt. I can write like this.
Yes.
Same equation I have rewritten like this. X at t plus h is equal to xt plus h times f of t xt. Now this is also a difference equation. You can see t plus h, and I am having here values in terms of xt, previous values. T plus h is like next values. Okay. Or we can rearrange also this difference equation. Let me. So to change the difference equation to more conventional form, we let xn is equal to x at t0 plus nh for n is equal to 0, 1, 2, and
1, 2, so on.
so what I will get here, then I will get
T0 plus nh,
xn plus
xn plus 1.
plus h times f of t0 plus nh into not into comma x of t is my xn. X at t0 plus nh is my xn. Okay. So I am replacing t by t0 plus nh. Okay. T0 is my initial point again. And for n is equal to 0, 1, 2, I will get next points of that interval, whatever may be the interval. Is that okay? T I am replacing to t0 plus nh. So this xt will be x at t0 plus nh, but x at t0 plus nh is nothing but my xn. Is that okay? What will be this? t0
मॅम
plus.
समजलं ना, रिपीट करा ना.
What we are doing here. इथपर्यंत okay का?
येस मॅम, ते लेट पासून आहे.
It is just a rewritten form of that above approximating value. Okay. Now what we are doing, we are replacing T by T0 plus NH here. T by T0 plus NH, and I am denoting this value. I am denoting this value by Xn. So let Xn is nothing but my X at T0 plus NH. Nth iteration, or you can say nth value, will be T0 plus NH. So what I am doing here, T0, sorry, T0 plus H, T0 plus 2H, T0 plus 3H, and so on. I am dividing that whatever interval into these parts, these points, T0, T0 plus H, T0 plus 2H, T0 plus 3H, and so on. So I am writing here T0 plus NH. So T0 plus NH is my nth point. Okay. नवगरे राणी
मॅडम म्यूटच आहे मॅडम.
नाही ना, इथे आवाज येतोय, मग unmute करते ना.
नाही मॅडम म्यूट केलं.
आवाज कुठून येतोय?
अनम्यूट कर.
अनम्यूट नाही, म्यूट करायचं. म्यूट म्हणजे बंद.
म्यूट
अनम्यूट म्हणजे
म्यूटच
बोलायचं.
आहे मॅडम.
आता बघा ना तुम्ही, इथे ते तुम्हाला दिसत नाहीये का?
म्यूट आहे, अनम्यूट आहे.
आता केलं, आता म्यूट केलं. म्यूट अनम्यूट काय चालू आहे, काही समजत नाही मला. Okay. So nth value of X at nth point is my T0 plus NH. I am denoting by Xn. Okay. So Xn I am considering as X at T0 plus NH. So for n is equal to 0, 1, 2, and so on. So X1 will be what? X at T0 plus H. X2 will be X at T0 plus 2H, and so on, right? This is my, at this point, it will be my X0. At this point, it will be X1. At this point, X2, value of X, here 3, and so on. Is that okay?
Yes, ma'am.
Yes, ma'am.
So now,
Yes ma'am.
so T is any point na, in that interval, whatever may be that T. So I am replacing now T by T0 plus NH. So it depends on N. What will be that point? Okay. So now if I replace T by T0 plus NH, so what will be this?
बाथरूम मध्ये जाऊन डायरेक्ट इकडेच आहे बघ, आमच्या बाथरूम मध्येच आहे.
X at T I am replacing by T0 plus NH and plus H. Okay. So which is equal to X at T0 plus NH plus H times F at T0 plus NH into, not into, comma, X at T0 plus NH. Is that okay?
Yes, ma'am.
मॅम
What I did here only, I replaced T by T0 plus NH.
T0 plus NH.
Plus H as it is. And here T0 plus NH, T0 plus NH, T0 plus NH. Nothing I did here. Okay, I am replacing in this equation. In this equation, as T is equal to T0 plus NH, means at different points I will have its value. Is that okay? Now, what will be this? T0 plus
Plus 1 N plus 1H.
H, which is equal to, this is nothing but my Xn. Is that okay?
T0 plus NH
That is plus H times
plus H time
this is
T0 plus NH.
T0 plus NH.
I have replaced by T. Because T I am replacing now.
T0
T T को replace किया ना पहले.
Plus NH.
बरोबर आहे.
That is nothing but
comma
XN
XN.
plus NH is nothing but XN.
XN.
Okay. Now what is X at T0 plus N plus H?
XN plus
XN
1.
plus 1.
So it is X at T0 plus NH.
NH, comma XN.
The same thing I have written here. Is that okay?
Yes, ma'am.
Yeah. Or I will erase this one and so instead of writing directly, consider let xn is equal to x at t0 plus nh and t is equal to t0 plus nh. Then whatever equation number, this star can be written as below. Okay, now is that okay?
Yes, ma'am.
Yeah. Now xn plus 1 is equal to xn plus h times f of t0 plus nh comma xn. Now this is n plus 1th value of that function we can represent in the form of xn, previous values. So again, this is one kind of difference equation. In numerical analysis, we come across to this such type of difference equations. Is that okay? So this is another type of difference equation. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Yes, ma'am.
I think now all the problems we have considered. This is not that much. Another is a 3x plus 1 problem also I will write it. Or I will write now another example. (1.7) that is called as the 3x plus 1 problem. In this also we come across to some difference equation. So what is that problem? It is a example of non-linear, which is example of non-linear difference equation. I will write that xn plus 1 is equal to xn by 2 if xn is even and 3xn plus 1 by 2 if xn is odd for n greater than equal to 0, where we choose x0 to be a positive integer, where x0 is positive integer. So this type of problem is known as 3x plus 1 problem. What is that? Xn plus 1 is equal to xn by 2 if xn is even. It depends on even or odd. If my nth term is even, then my n plus 1 term is xn by 2. If xn is odd, then my next term is 3xn plus 1 by 2. So this problem is known as 3x plus 1 problem. Okay. And there is nothing, actually it is non-linear type of difference equation we will come across. So we can also write equivalently, we can write above equation as follows. Now xn plus 1 is equal to xn plus 1 by 4 minus 2xn plus 1 divided by 4 cos pi at xn. Because of this term, it is getting like non-linear term, okay? Non-linear difference equation. We are not yet come across about linearity, non-linearity, but it is one of the example of non-linear, which is example of non-linear difference equation. Why it is difference equation? Because n plus 1th term and it is a relation between n plus 1th term and xn, xnth term, nth term, right? But this, due to this form, it is coming into non-linear term. Okay. So how can we write like this? Can you see these two are same? This is just another form of difference equation. Xn plus 1 is equal to xn by 2 if xn is even. Why it is like that? Can you simplify this? If my xn is even, what will this equation becomes? What this term becomes?